In this video, we are going to explain 3 different experiments about electromagnetism, but first we need some theoretical basis. Faraday's law of induction is a basic law of electromagnetism, which predicts how a magnetic field interacts with an electric field. This phenomenon is known as an electromagnetic induction. According to the Maxwell-Faraday equation, the tension induced onto a closed circuit is proportional to the speed with which the flux of the magnetic field varies with time.
For example, if we have a closed spire made of a conductive material and there's a magnet nearby, when it's at rest, as the magnetic field is constant, its derivative is zero, so there is no electric field. However, if the magnet starts moving, the magnetic flux going through the spire will change, which will induce an electric current onto the spire. The closer the North Pole, the more intense will the electric field be.
Meanwhile, as electric fields also create magnetic fields, the current in the spire creates a magnetic field opposite to the magnetic flux of the magnet. This phenomenon is explained by Lenz's law, which is a consequence of the conservation of energy. This means that in a way, the electric field creates a magnet turned around to oppose the magnetic force.
For the first experiment, we need some neodymium magnets and 2 1-meter long tubes, one made of aluminium, which is a conductor, and one made of plastic, so neither of them are attracted by the magnets. We have released 2 equal magnets inside the tubes, and observed that the one going through the aluminium takes a lot longer to reach the ground. The tube is made of thousands of thin spires, so when the moving magnet goes through them, an electric field is created, which creates a magnetic force upwards opposing the force of gravity.
For this second experiment, we have connected 2 clips to the poles of a battery and made various spirals with a copper wire and connected everything. Then, we have placed the magnets above the battery and made the spires spin. We have observed that the spires keep on spinning because even if the magnetic field created by the magnets is constant, the area that the field lines cross changes, so the flux changes, which induces an electric field onto the spire, making it keep on spinning.
When the magnet tied to the string is at rest, the magnetic field is constant, but when it starts moving, it becomes non-constant, so an electric current is induced onto the aluminum cup. As the cup tries to cancel out the effect of the magnetic field, it starts moving in the same direction as the magnet. At one point, the magnet stops, but it starts spinning in the opposite direction because the magnetic field is constant again, and thus there is no current in the cup.